All right, guys, welcome. Sorry I'm not here today, but Mr. Livingston, I'm sure, is doing a wonderful job and can direct you with all of the stuff that I'm about to go over. So first off, make sure that you complete the lab, the efficiency lab that we did last time first before doing any of this. But once you're done with the efficiency lab, the next thing you're going to do is this solar panel inquiry lab. So the lab that we're going to be doing, this inquiry lab, is going to serve a couple purposes today. So today you're going to kind of have like a play day to kind of just get a feel for the sensors that you're going to be using and the setup that you're going to use, and then just trying to collect some data and look at the relationship between output from the solar panel and things like the angle of the solar panel and the distance of the solar panel from a light source. So the things that you're going to need, first off, you have a meter stick. They're in the front of the room over here. You have a lamp with the incandescent bulb already in it. Those are in the back of the room. You'll have an energy sensor, this little device right here, which will be in the box in the front of the room. A solar panel, which is also in that same box. A LabQuest 2, which Mr. Livingston will get for you, and then a ring stand that already has the clamp here that you can clamp the solar panel to. So I have a setup here in the front, so I'm going to rotate this for you so you can see what I'm doing. So you're going to have to do this around the back of the room, and so I've just put the panel in here and made it vertical like this. I have hooked up using alligator clips, which are also going to be in the front of the room here, from the two leads of the solar panel going into the source of the energy sensor. So if you unscrew these right here, there's a little hole, and you can put the alligator clip right into that and just clamp it down. Then the LabQuest 2, in the very front of the LabQuest 2, there are two ports, and so you don't have to open anything up, and you just put those right in here. I know Mr. Livingston has used these before, so he'll be able to direct you with that if you have any questions, okay? So these two leads from the energy sensor go right into the LabQuest right here, okay? Then once you have that done, the on switch, hold on, for the LabQuest 2 is right on the side right here, and I know you can't see it, but there's a little button, there's a little red button. You push that, it'll turn on. It should auto-recognize the energy sensor, and once you turn it on, you should see 4 displays, and those displays are potential, current, power, and resistance. And you should immediately get a reading. So my reading is, and they're negative numbers, don't worry about negatives, negative 0.58 volts, negative 1.9 milliamps, the M there stands for milli, 1.1 milliwatts, and 298 ohms, okay? And so those numbers, and we'll talk more about those later, you can just kind of look at those and just get a feel for that. So there is a background amount of energy that the panel will produce, and that's going to become important. So you should note that before you do anything about turning on the light or anything like that. Now I've set it up like this, and then I can use my meter stick, lay it down, and set my lamp a certain distance away. Make sure the light is kind of angled toward the lamp, towards the panel. And then when I turn this on, if I look at my readings now I am at negative 2.26 volts, negative 1.6 milliamps, 3.6 milliwatts, and I'm up to 1,431 ohms. Now from here, I do want you to collect data. I do want you to play, kind of move this around, do whatever, but think about how you can run a good experiment and what you're going to change. And remember, when you alter a variable, you alter one variable at a time. And so the two things you're really going to look at are distance of the panel from the light source and the angle of the panel relative to the light source. So you do need to get a control, like a set data. So say at 90 degrees relative to the light and a certain distance away, you're going to collect some data. Okay, record that data. So make a spreadsheet in Google Sheets and record some data about this setup right here. Also do it with no light on, just some ambient light, because it is producing some things right now. Then you turn the light on and collect some data. And then you're just going to alter either the distance or the angle of the panel. You'll have a protractor available, you've got your meter stick available, and play around, but make sure you are collecting data and you're doing it in a way that's methodical, where you're saying, I'm going to change the distance this much and record each time. I'm going to change the angle this much and record each time. All right, guys, I decided to make a data table for you just so that we all have the same data and it looks the same, and we can compare that and talk about it in class. And then we'll run a more guided experiment on Monday, okay? So this is the data table I made. One data table for distance of the panel and one data table for the angle of the panel. And so please be really careful that you fill in this right here. So when you're going to test the distance of the panel, make sure you tell me for what angle. So are you going to do a 90-degree angle relative to the light? If you are, then record that here. If you want to do a 45-degree angle or whatever, that's fine. Just make sure you record what angle you used, and then you're going to alter your distance, okay? So record that in centimeters, and then just fill in the numbers for potential current, power, and resistance. I put power in green because this is the one that we're going to concentrate on, and I'll explain why when we do this on Monday, okay? The other thing is record the data for the light being off, and then once you turn it on, then you'll record all your numbers. But I do want to know what the background numbers are before you turn on your lamp. And the same thing goes with the angle of the panel. And the numbers are going to fluctuate a little bit. Just like kind of look at it, look at the meter, and you can make a graph of it, but it's just easier. Just look at the meter and just kind of get an average number in your head and record that. And so this data is more for a talking point as we move forward on Monday. And then again, we're going to concentrate on the power. So distance of the panel and then the angle of the panel, use your protractor and alter the angle of the panel. But again, do it for a set distance. So don't change the angle and then move your panel forward or something like that. You just got to keep it at the same distance and then alter the angle. Keep it at the same angle and then alter the distance, and just collect. And I just put a bunch of different things here. You can add more data if you have time. Remember, more data is better data. And then have a wonderful weekend, and I will see you guys on Monday.